Okay, so here we're talking about combining like radicals. It's really a lot like combining like terms. So notice here we have 6 square roots of 11 and 9 square roots of 11. You can really treat that square roots of 11 sort of like a variable. So 6 of these, 9 of these, together that's 15 of them. Likewise, you can subtract. Remember, there's a secret 1 out in front here, so it's 1 square roots of 3 minus 5 square roots of 3. That's technically negative 4 square roots of 3. Again, treating it like it's a variable. So if we take a look at A, I have 7 square roots of 2 minus 8 square roots of 2. That's negative 1 square roots of 2, or just negative square root of 2 if you prefer. And on B, we have 5 square roots of 5 and 2 square roots of 5. So that's 7 square roots of 5. So that's the easy part. Again, remember, you can only combine them if they have the exact same radical. Something else you have to look out for. When we're simplifying to combine like radicals. So taking a look at these two. 5 square roots of 3 minus square root of 12. Those are certainly not like terms. But hidden inside of the square root of 12 is actually a square root of 3. So think about it like this. You have square root of 12 is really the same as 4 times 3 on the inside. So it's 2 square roots of 3. Notice here square root of 3. So I really have 5 square roots of 3 minus 2 square roots of 3, which 5 minus 2 is 3, so 3 square roots of 3 is the simplified answer. Alrighty, so on A here, we have 4 square roots of 7 minus 2 square roots of 28, or plus rather, and we obviously can't combine those, but if we take a look at square root of 28 rather, that's like the square root of 7 times 4. So we have 4 square roots of 7 plus 2 times 2 square roots of 7. We can bring that 4 out, makes another 2. So 4 square roots of 7 plus 4 square roots of 7. That's a total of 8 square roots of 7. On B, something similar is going to happen here. So we start out with 5 square roots of 32 minus 4 square roots of 18. Again, hidden inside here, right? So 5 square roots of 16 times 2 minus 4 times 9. Again, on the inside, 9, or square root of 9 times 2. Well, the 16 is going to come out as a 4, so 5 times 4 square roots of 2 minus 4 times, again, the 9 comes out as a 3. 4 times 3 square roots of 2. So 20 square roots of 2 minus 12 square roots of 2. Now, lucky us, we've got matching radicals, right? So we can go and subtract. 20 minus 12 is 8 square roots of 2. Part C here. Can you combine two unlike radicals when the radicands have no common factors other than 1? No, because that makes them unlike. And if we go back to your vocab, again, we obviously can't add or subtract. You can multiply if you want, but you cannot add or subtract unlike radicals. Okay, so here we're going to talk about, so we've already talked about adding and subtracting. Now moving on to multiplying. If I have a radical on the outside, I can distribute it just like any other number. So this becomes, 60, or square root of 60 plus 3 square roots of 10. And you can simplify from there. So we can distribute your property. If we have two factors in there, we can FOIL. And again, all the rules apply after you multiply them. So don't forget that FOIL method is one of those lovely things that we learned. So here, square root of 10 times, and then in parentheses, square root of 6 plus 3. You distribute that. So we end up with 10 times 6 inside, so square root of 60 plus 3 square roots of 10 right here. And we know the square root of 60 is 4 times 15, so I can pull that 4 out as a 2 square roots of 15, and then 3 square roots of 10, because again we're still out in front there with that. Nothing else I can do with these guys. This is absolutely as simple as we're going to be able to get it. Foiling in part B, so 6 square roots of, or I'm sorry, square root of 6 minus 2 square roots of 3, and square root of 6 plus square root of 3. So we go ahead and FOIL. Square root of 6 times square root of 6 is a positive 6, or square root of 36 if you prefer. Our middle term here, we're going to have negative 2 square roots of 18. Outer term is going to be square root of, let's see here, 18. Oh, that's right there in the front. And the last term is going to be a negative 2 square roots of 9. Again, 3 times 3 is 9. So foiling that out. Now we go back and take a look, and what can we do? Can we get some like terms? Well, I have 1 square root of 18 and 2 square roots of 18. Subtract there, I get minus 1 square root of 18. And then obviously the 9 comes out as a 3, so 3 times 2 is 6. Square root of 36 is 6, so bring that down. 6 minus 6 here, that's going to create 0, that's why that term is gone. And then negative 3, and leaving with the square roots of 2. So look back through that one again if you're not sure. But again, it starts out with foiling, then all these rules we've learned. And you will certainly see test questions like this. Okay, so moving on with a little bit of practice here. Again, we said we can distribute this. So we get square root of 2 times square root of 6 is the square root of 12. Plus 5 square roots of 2. Obviously, we're taking a look here, square root of 12 is not in simplest form, so that is important. Inside there is 4 times 3, so it's a square root of 4 times 3 plus 5 square roots of 2. Come along for the ride. 4 comes out as a 2, so 2 square roots of 3 plus 5 square roots of 2. In B, I'm going to rewrite this so that it's, I'm going to basically write it out twice here. So square root of 11 minus 2 times the square root of 11 minus 2. Now I'm just going to FOIL. So square root of 11 times the square root of 11 gives me 11. And then minus 2 square roots of 11 minus another 2 square roots of 11, because again we're foiling. And then plus 4 at the end. These two are certainly like terms, so 11 minus 4 square roots of 11 plus 4. 11 plus 4 is 15. Minus 4 square roots of 11. Nothing I can do with the square root of 11, so that is the answer. Now, the third one here, I'm just going to go ahead and FOIL that out for us. So we're going to have square root of 6 times 4 square roots of 3. That's 4 square roots of 18, because again, 6 times 3 is 18. Minus 8 square roots of 9. Plus 3 square roots of 36. Now, I know those are perfect squares, and I'll pull them out here in a minute. I just want to make sure you see where they're coming from. Minus 6 square roots of 18. Now we've got 4 square roots of 18 minus 6 square roots of 18. That's negative 2 square roots of 18. Again, I know there's a 9 going to come out of there, but we'll do that in a minute. And this becomes 24, right? 8 times 3, so minus 24. This is 3 times 6, so it's plus 18. Negative 2 square roots of 18 minus 6. Again, we combine like terms here. Now we're going to pull out that 9, so negative 2 times, and then again 9 times 2 on the inside, minus 6. Bring out that 9 as a 3, so negative 6 square roots of 2, and then minus 6. And there we go. That's it. You can't go any farther. There's no way to combine those. Okay, so we need to rationalize this. Notice here I have square roots, right? So radicals in the denominator, not allowed. So we're going to use that term we talked about earlier called conjugates. So if I take a look here, this is 7, or negative square root of 7 minus square root of 2. That doesn't become square root of 5 or anything, right? So, but we want to get rid of the radicals there, so we're going to use the conjugate. In other words, I'm going to put a plus instead of a minus in the middle. And I'm going to put that on top and bottom. That's my well-chosen one. So again, notice that we have the same thing on the top and the bottom, so it's technically the number 1. So I'm going to multiply top and bottom. This is where you have to FOIL. So the top becomes pretty easy. You're just going to distribute, right? 10 square roots of 7, and 10 square roots of 2, right, on the top there. Now, you can, I guess they left it here. They didn't distribute that, so we won't either. We'll leave it like that for the moment. On the bottom, again, here, this is like a difference of squares, sort of in reverse. So when I FOIL that out, that is going to become 7 minus 2 square roots, or minus square root of 14 plus square root of 14, and then it's going to be minus the number 2. So when you FOIL that out, let me do that for you to make sure we got it. So again, the square root of 7 times the square root of 7 just becomes 7. Middle term is going to be negative square root of 7 times 2 is 14. Outer term is going to be plus square root of 14. And the last term is going to be minus, again, square root of 2 times square root of 2 is 2. Notice these middle terms drop out. So we end up with 7 minus 2 there, which is 5. So that's where this 5 comes from. Now, you'll notice I can take, and you got to look for these things. The 10 divided by 5 is 2. So we end up with this 2 times the square root of 7 plus square root of 2. So now I distribute that 2. So 2 square roots of 7 plus 2 square roots of 2 is what we end up with there for the answer. And you can't do anything further than that, but it is certainly in its simplest form. So let's take a look at the got it 4 here. So we're going to take that and we're going to multiply by the conjugate of the denominator. So again, the conjugate means I just turn this positive into a negative. So square root of 10 minus square root of 5 over square root of 10 minus square root of 5. And on the top, that's going to give me negative 3 times times square root of 10 minus square root of 5. And on the bottom, it's going to conjugate. In other words, it's going to wipe, from previous experiences we saw over here, it's going to wipe out all those middle things. So it's really just going to become 10 minus 5, which, by the way, if you didn't know, is 5. So on the top, then, we're going to distribute that negative 3, so I'm getting negative 3 square roots of 10. And here, negative 10, negative is positive, so plus 3 square roots of 5. And that is the simplest form of this. Alrighty, so on this last one here, this is one of those contrived, real-world type things. Anyway, let's explain what's really going on here. First off, you have the golden rectangle. And it says that the golden rectangle has a ratio of length to width of this. So it's really a fraction. In other words, if I talked about length and width, I'm going to grab my marker here, length and width, they really are this number, right? 1 plus square root of 5 over 2. That's really what all this is saying. Kind of weird, but, whatever it is. Now, here's the thing. I'm going to give you the length. I'm going to tell you the length is 4 centimeters, and you're going to solve for the width. That's just going to be a little bit of, cross-product fun. So, what this looks like here, so we've got 1 plus square root of 5 for the length, and again, the length is 4. 2 for the width, again, in the ratio itself for the golden ratio, or the golden rectangle, and then W is the unknown width that we're solving for. Cross product fun here, 2 times 4 is 8. Distribute the W, so W times 1 plus square root of 5. And so we're going to go ahead and then, as we're going to solve here, we're solving for W, you divide off the 1 plus square root of 5, goes to the denominator. Well, that leaves us with kind of a dilemma here, because we now have a radical in the denominator. So you're going to use your conjugate, and we get 1 plus square root of 5 over 1 plus square root of 5. And go ahead and multiply that out. We know that this is going to yield 1 plus 5 on the bottom. And here I'm going to distribute. It's going to be 8 minus 8 square roots of 5. Becomes negative 4 on the bottom. You can go back. You can divide out the 4s, right? In this case, I guess a negative 4 if you prefer. And that leaves us negative 2 plus 2 square roots of 5, which is about 2.5. So a lot of work for something that they try to make real world, but you betcha, loads of fun. I'm going to use some from the previous example for this right here. So suppose this time it's 12 inches long. So instead of 4, there's a 12 here. That's going to be the only difference. So I'm going to rewrite that. That becomes 1 plus the square root of 5 over 2 equals 12 over W. A little cross product fun here is going to yield the following. W times 1 plus square root of 5 equals 24. We're going to want to go ahead and then divide off that 1 plus square root of 5 from both sides. So that's going to mean W is 24 over 1 plus the square root of 5. Obviously, in order to solve that, I'm going to have to go ahead and use the conjugate. So we're going to multiply this by, again, a well-chosen 1. So I don't have to multiply the other side by it because I'm multiplying by technically 1. That's why we get away without that. So 1 plus square root of 5, because again, minus rather, not plus, because this was already plus, over 1 minus square root of 5. And on the top, that's going to yield 24 times 1 minus the square root of 5. On the bottom, that's going to be 1 minus 5. So continuing, 1 minus 5 is negative 4 on the bottom. So on the top, 24 minus 1 squared is 5. I can now go ahead and reduce here, right? So I get negative 6 times 1 minus square root of 5. Now we can go ahead and distribute, so we'll get negative 6 plus 6 square roots of 5. Obviously, kind of to turn that around, so 6 square roots of 5 minus 6. There we go. And that's inches is the exact answer, or again, if you throw it into a calculator, about 7.4 inches.